Welcome back. This is our third video in the equations topic, and today we're going to be looking at equations that involve fractions. Alright, so what do we already know about fractions in algebra? We've already done some of these in the previous lesson. Firstly, remember that x divided by 5, of course, in algebra can be written as x over 5. So the opposite of x divided by 5 is timesing by 5. So that's our inverse operation. So we're going to use that to solve our first problem here, example 1. Here we've got x divided by 5 is equal to 8. And again, I'm going to use the idea of equivalent equations. And I'm going to be thinking of how I can make this equation look a little bit simpler. And of course, that would be to remove this dividing by 5. The opposite to dividing by 5, remember, is to times by 5. And as long as I do that to both sides of the equation, then I am creating an equivalent equation. Now I want you to remember that when you are dividing a fraction by 5, you write it over 5. When you are multiplying by 5, 5 goes up the top, so that these two, in effect, cancel out. That's why we times by 5 in the first place. On the left hand side now, I'm left with x, and on the right hand side, I'm left with 8 times 5, which is 40. Remember, you should always do a quick check to see if your answer makes sense. Does 40 up here divided by 5 equal 8? Yes, it does. Alright, so that's a fairly simple one-step equation that we've been able to solve a number of different ways in the past. Of course, they're going to gradually get harder. So we'll have a look at the second example here and make some decisions about what we need to do. Now, I have said in an earlier video that the general idea is to remove what is furthest away from the x, generally speaking. So in this case, dividing by 5 is the thing that's happening, that's furthest away. That's the one that we're going to undo first. So again, I'm going to multiply both sides by 5. Very similarly to the last example. So that means timesing by 5 up here, timesing by 5 up here. We've done that so that these 5's cancel down, simplify, and all I'm left with now is 2x is equal to 8 times 5, which is 40. Okay, so I've got a much simpler looking equivalent equation, but I've got one more step to go, and that is to remove the 2. At the moment it's timesing by 2, so I'll remove it by doing its inverse or dividing by 2. In this case, 2x divided by 2 will become x, and 40 divided by 2 will become 20. A quick check in here, 2 times 20 is 40, 40 divided by 5 equals 8, so yes, I know that my answer is correct. Okay, let's have a look at one that's getting slightly harder again. Example 3 is what I would call a three-step equation. It's going to take us 3 steps before we can get the x on its own. I'm going to consider what I need to undo first. So if I have a look at this x, I would say that it is being multiplied by 2, then I'm adding 16, and then finally I'm dividing that result by 5. So the last thing that I said I was doing, dividing by 5, is going to be the first thing that I'm going to undo. So we're going to undo that by multiplying by 5. Okay, again, remembering that I'm multiplying by 5 up the top here, so that they will cancel out. And whatever I do to the left-hand side, I have to do to the right-hand side. So what I have left on the left-hand side now is 2x plus 16. And what I have on the right hand side is 40. Okay, using that principle again of trying to make our equivalent equations a little bit simpler each time, this time I'm going to have a go at removing the 16. It's adding, so I'm going to be subtracting. What am I left with on the left hand side? 2x. What am I left with on the right hand side? Whatever 40 take away 16 is, which in this case is 24. So my last step is to work out 2 times what equals 24. So I'm really thinking about dividing both sides by 2. And I get x is equal to 12. If I substitute my 12 back up here, 2 lots of 12 is 24. 24 plus 16 is 40. 40 divided by 5 equals 8, so I know that my answer of x equals 12 is correct. Okay, example 4, again another 3-step equation, but this time if I said, tell me what's happening to the x, I'd say that we are multiplying by 2, then we are dividing by 5, and then finally we are adding the 16. So the last thing I said was adding 16, so it's going to be the first thing that I undo. And the opposite to adding 16, of course, is taking away 16, so let's do that. When I take away 16 from up here, this plus 16 take away 16 disappears, so I'm just left with 2x divided by 5. And when I take away 16 from this 8, I end up with negative 8. So there's one equivalent equation that's a little bit simpler than the first version. This looks pretty similar to one that we've solved on the previous slide. I'm going to again remove the thing that's furthest away, which is the dividing by 5. So I'm going to times by 5, times by 5. So what am I left with on this side? 2x, and on this side, negative 40. And finally, I need to undo the timesing by 2, which I do by dividing by 2. And I end up with x is equal to negative 20. If I substitute that in up here, 2 lots of negative 20 is negative 40. Negative 40 divided by 5 is negative 8. Negative 8 plus 16 equals 8. So I know my solution is correct. Okay, final example for today. 20 take away 2x over 5 equals 8. So I'm going to remove the thing that's furthest away, which in this case is the 20. It's positive, so I'm going to take away 20 from both sides as my first step. I'm going to end up with negative 2x over 5 equals negative 12. Notice that just for ease sake I've made this fraction up here, I've made the numerator negative. Okay, so that minus sign is attached to that 2 now. Alright, I'm still removing things bit by bit as I go. This time I'm going to undo the dividing by 5. Just timesing by 5. So notice that on the left hand side the 5's just disappear. But on the right hand side something happens. Negative 12 times 5 is negative 60. One step to go, I need to remove the negative 2. The negative 2 is timesing the x, so I'm going to divide by negative 2. Again, I have to do it to both sides to keep things balanced. When I divide negative 2x by negative 2, I'm just left with x, which is what I'm aiming for when I'm solving equations, is to get the variable or the pronumeral on its own. And then on the right hand side, I need to do negative 60 divided by 2, which will be just 30. And there's my answer to the equation. So that's it. A variety of questions, all involving fractions, with some approaches which are slightly different for each one of them, depending of course on the order of operations. Okay, so now it's over to you. You've watched the video, you've written down the examples. Now you need to write a brief summary in your own words, and of course write down any questions you've got and bring them back into class. See you next time.